Hello student, myself Millie Sankla, and in today's session we derive the again new derivation of fixed beam subject to rotation. Okay, and this topic is our topic of fixed beam. Now we start with our derivation, and to prove this derivation, first of all we read the given data properly and then we derive the equation of rotation. Derive the equation for fixed end moment. Develop if support B of fixed beam AB rotate by at angle B in clockwise direction. Okay, here our support B is rotate by at angle theta B in clockwise direction. Okay, now we prove this derivation. Again we use a theorem, moment area theorem, right here. To prove this derivation we use our theorem, moment area method. Okay, to prove this derivation, write down, we use a moment area method. Now mention the point A and B. Here in data mention that support B rotate by theta B. Okay, support B rotate by theta B in clockwise direction. This direction is clockwise. Okay, simple. Now if our support B rotate by in clockwise direction, support B resist this clockwise rotation in anti-clockwise direction. Okay, and to resist this anti-clockwise, support A rotate in clockwise direction. Write down, this support induce moment at B and this support induce moment at A. Okay, this is the sign convention only assumption. If my answer is opposite, then I will change this sign convention because my answer is right. Now moment area method, write down here. First we use, again the rotation is our unsymmetrical loading, and for this unsymmetrical loading we use two theorem. First theorem for area and second theorem for deflection, that means area into CG. Now make a heading here, moment area theorem number 1. Write down moment area theorem 1. Okay, moment area theorem number 1. And this theorem is A plus A dash is equal to 0. Not 0 because support B rotate by clockwise direction. That means this is right hand side clockwise. Sign convention say right side clockwise is equal to minus theta B. In first settlement deflection occur and deflection is equal to area into CG. So effect of this deflection I take in second moment area theorem number 2. But here in this derivation support B rotate, that means this is the effect of slope and we have to take this effect in equation number theorem number 1. Now one by one we draw the diagram for that. First, this is our clockwise moment of left hand side, that means plus. Okay, and height of this moment is equal to MA by EI, and this point is our A point and this point is our B point. Now simple, connect this point. Okay, because when I am drawing diagram of MA, at that time B point is 0. Okay, plus and distance is equal to L. Right here, this is the diagram for MA. Now second, when I am drawing diagram of MB, at the time MA is equal to 0. Right here MB by EI. Okay, this point is A point and this point is B and distance is equal to L. Simple, again connect this 2 point. Okay, MA and this is our B point, that means like this way. Okay, plus diagram. Okay, now A and B, and this diagram is for MB moment. Now one by one put the values. Now A is equal to area of this diagram and A is equal to area of mu. Simply here I write down A is equal to area of mu diagram according to our step of moment area method, plus A dash is equal to area of mu dash diagram. Okay, simply mu dash diagram is equal to minus theta B. Now mu diagram means this diagram and mu dash diagram means this second diagram. Now area of first diagram, again triangle, area of triangle is equal to 1/2 into base L and height is equal to MA by EI, plus second diagram 1/2 into L into mb by ei, and my here minus theta b. Now common values are L by 2i, okay, common value into L by 2i, and again first term with left with MA and second term with left with MB, and minus theta B. Now MA plus MB is equal to, cross multiply this term, so minus 2ei theta B divided by L. This is my first equation due to moment area theorem number 1. Now here I take a second theorem, moment area theorem number 2. Okay. Now next, moment area theorem number 2 right here. Moment area theorem number 2 is for deflection. Okay. But in this, right, first of all make a heading, then I explain you moment area theorem number 2. Moment area theorem number 2. Okay, now moment area theorem number 2 is for deflection, and support B rotate, that means we have to take a CG from support B. A xb plus a dash x dash b is equal to 0. Here why we take a 0? Because here support B rotate, so that deflection is equal to 0. In first case support B deflect, so that I take a effect of this deflection in moment area theorem number 2. And in this case support B rotates, so I take a effect of this rotation in moment area theorem number 1. Clear this concept? Rotation, slope are take in first moment area theorem number 1, and deflection are take in second number theorem, moment area theorem number 2. Deflection, settlement or sink. Okay, now one by one. A is equal to area, that means our triangle, 1/2 L into MA by EI, and from B point, that means our apex, 2/3 into L, 2/3 into L, plus second 1/2 into L into MB by EI, and from B base 1/3 into L is equal to 0. Now simplify. First 2 right here, 2 MA L square, then 6 EI plus second MB L square 6 EI is equal to 0. Now what is the common value from first and second? L square by 6EI, common term separate out, L square by 6EI, and in bracket first term left 2MA and second left MB is equal to 0. Now cross multiply this term, that means our answer is equal to 2MA plus MB is equal to 0. Now according to this, if I want to make a subject moment A is equal to minus MB by 2. This is my second equation for deflection. Okay, moment area theorem number 2. Now our first derivation was 2MA plus MB is equal to minus 2EI theta B by L. This is my first derivation. Now here I put the value of MA is equal to minus MB by 2. Okay, my first derivation is equal to MA plus, sorry, not 2MA plus MB minus 2EI theta B by L, and put the value of this MB. MA is equal to minus MB by 2 plus MB is equal to minus 2EI theta B by L. Now here LCM is 2 means 2 MB. Okay, I am simplify this term, 2 MB minus MB, and cross multiply this 2, minus 4EI theta B by L. That means my answer of MB is equal to minus 4EI theta B by L. This is my first moment. Now here I find out my second moment. What is MB? MB is equal to minus 4EI theta B L. So right here MA is equal to, write down MA is equal to minus MB by 2. Okay, now MB minus and value of this MB we find out 4EI theta B by L and 2 also. Now minus minus is equal to plus, so my answer of this MA is equal to 2EI theta B by L. Now one by one indicate the sign of this moment on this beam AB. This is the moment MA, that means positive, left hand side positive, that means sign is clockwise and value is given 2EI theta B by L. And this is our B side, that means our right hand side. Answer of this right hand side is negative, that means negative value on right hand side is equal to clockwise, and this is our 4EI theta B by L. Okay, now in this derivation we find out two value of this A and B point for rotation of fixed beam, and from this value of moment we find out support direction. Okay, so first of all this is our A point, this is our B point, and value of this B point we get 4EI theta B by L, and value of this A point we get 2EI theta B by L and distance L. Now to find out support reaction, right here taking moment about A. With any point we take a moment, taking moment about A. That means anti-clockwise moment is equal to our clockwise moment. Suppose support B rotate RB with rotate respect A about anti-clockwise. So write down on anti-clockwise side RB into L, and these two moment are clockwise. So write on clockwise side. First moment is our 2EI theta B by L plus our second moment is equal to 4EI theta B by L. Now answer RB is equal to 6EI theta B by L square. This is our upward. So second support reaction RA is equal to downward, because here no vertical load are given. Okay, one support is up, the second support is our down support. Okay, now mention here our RA is equal to in downward direction and RB is in up direction. Now first we draw the diagram of SF. Now what is the sign convention of SF? Upward, upward, downward, downward, plus, minus, minus, plus. Now this is the left hand side down, that means we draw in down direction, and this is the right hand side upward, that means again minus, we draw in down direction. Okay, and value are constant, and that is 6 EI theta B by L square. Okay, minus, this is our reference point A, this is our reference point B, and 6 EI theta B by L square, and this value is also 6 EI theta B by L square. And this is our SFD diagram. Okay, right here this is our SFD diagram. Now for bending moment diagram, again draw the sign convention clockwise, clockwise, anti-clockwise, anti-clockwise, plus, minus, minus, plus. Okay, now at left hand side clockwise, that means upward, plus. Okay, like this, and here right hand side clockwise, that means look at this minus, draw in down direction. Okay, like this way. Now simply connect these 2 points. Okay, because left side of plus, this is plus moment and this is minus. Value of this RA is equal to given 2EI theta B by L, 2EI theta B by L, and value of this RB is equal to 4EI theta B by L, and this is the diagram of bending moment. Okay, here now we complete our derivation of fixed beam subject to rotation. Now next we solve our example of fixed beam. Okay, and our first example we start with our moment area method. Okay, now we solve our example of fixed beam. Okay, now first of all read the given data and which values we find out here. analysis the fixed beam as shown in figure using moment area theorem. Okay, here method is mentioned that we solve this example, we analysis this fixed beam with moment area method because rule of moment area and Macaulay's are different. Okay, here method is given so that we solve this example particularly by this moment area method. Okay, now what is the moment area method? First of all, we check the given beam. If our given beam subjected to unsymmetrical loading, then we use two moment area theorem, theorem 1 and theorem 2. If our given fixed beam subjected to symmetrical loading, then it is solved by one theorem, moment area theorem number 1. Look at this. This is distance 3 meter. Now here is distance 2 meter. That means this given beam is unsymmetrical loading. So that here we solve this example with two moment area theorem, theorem 1 and theorem 2. Now one by one we start. Okay, step number 1, convert the fixed beam into simply supported beam. Okay, this is our first point and this is our second point, A point, and this is B point. Now convert this fixed beam in simply supported beam. Okay, given distance is 3 meter and this distance is 2 meter. Now bending moment diagram of eccentric point load is same as point load. Okay, concentrate point load, but here moment are different. Suppose this is our C point. Okay, I am giving notation here, C point AB. Now find out moment at C. What is the equation of moment at C for eccentric point load? That is W AB by L. Now W is given 20, A is given 3 meters. This is first distance is A, and B is given 2 meter. Okay, and total span is equal to 5. 3 plus 2, 5. Now our answer is equal to 24 kilonewton into meter. Simply write here moment is equal to 24. Okay, and this diagram is known as our mu diagram. Okay, this diagram is known as our mu diagram. Now next step, apply hogging moment. This is distance is equal to 5 meter. Okay, this is our A point and this is our B point. Now apply hogging moment MB and here the moment MA. But here fixed beam subjected to unsymmetrical loading, that means MA not equal to MB. If our fixed beam subjected to symmetrical loading, in this condition MA is equal to MB. But here unsymmetrical loading, so MA is equal to MA not equal to MB. So here I draw two separate diagram. Okay, first is our anticlockwise moment, this is minus, and mention here this is our moment MA and this is distance L, that means our 5 meter. Now mention A and B. I draw two diagrams separately because in this diagram we have to take area into CG. Okay, now this is A point and this is B point, and height of this moment is equal to MB and distance is equal to 5 meter. Again mention 5 meter, and this two diagram is known as our mu dash diagram. Okay, now one by one we use a moment area theorem. First mention here moment area theorem number 1. Okay, moment area theorem 1. Moment area theorem 1. What is moment area theorem number 1? A plus A dash is equal to 0. Now what is A? A is equal to area of mu diagram. Okay, and A dash is equal to area of mu dash diagram. Okay, simply we have to take area of two diagram. Now first, here distance is given 5 meter. So here we take area of triangle 1/2 into distance 5 into 24, and two triangle are given 1/2 into 5 into MA, 1/2 into 5 into MB. Okay, right here 1/2 into 5 into MA plus second 1/2 into 5 into MB is equal to 0. Now after simplification, MA plus MB is equal to minus 24. Okay, after simplify this calculation, we have to get our first equation due to moment area theorem number 1, and that is MA plus MB is equal to minus 24. Now, again make a heading, moment area theorem 2. Moment area theorem 2. Okay, now moment area theorem 2 is based on deflection. That means right here AXA plus A dash X dash A is equal to 0. Now here I consider A point. We can take B also. Answer will be not changed. Okay. We can take CG A point also. We can take CG B point also. Okay. Here I take a CG from A point. Now guys, AXA means we have to follow this first diagram, and A dash X dash A means we follow this diagram. Now here is triangle is given. Now for area into CG, I divide this triangle in two parts. Okay, first, and this distance is equal to 3 meter and this distance is 2 meter. Because we take a area into CG. I am giving a number. This is our first area into CG. This is third one. Okay, sorry, second. This is third one. And this is our fourth one. Now one by one. Okay, first area. 1/2 into 3 into 24. And CG is taken from this point, that is 2/3 into 3. Okay, I am writing here area into CG 1/2 into 3 into 24, and CG is taken from A point, that is 2/3 into 3 plus, now the second triangle 1/2 into 2 into 24, and we have to take CG from A point. So first add 3 meter distance and base of triangle 1/3 into 2. Clear? Okay, mention here 1/2 into distance 2 meter, then 24 from ACG 3 plus base of 1/3 into 2. My mu diagram is complete. Now I take mu dash diagram 1/2 into 5 into MA, and from ACG 1/3 into 5. Okay, mention 1/2 into moment at A into distance 5 and CG 1/3 into 5 plus second diagram 1/2 into 5 into MB and CG 2/3 into 5. Okay, 1/2 into 5 into MB and CG is equal to 2/3 into 5 is equal to 0. And after solving this calculation, answer is equal to MA plus 2MB is equal to minus 38.4. Okay, this is my second equation due to moment area theorem number 2. Now again we carry forward this example. Now here I get two equation of moment area theorem number 1, and second equation is moment area theorem number 2. Write down one by one here. Our first equation is MA plus MB is equal to minus 24, and our second equation is MA plus twice MB is equal to minus 38.4. This is my first equation and this is my second equation. Now solve these two equations, and after solving these two equations, my first moment MA and my second moment MB. My moment MA is equal to minus 9.6 and my second moment MB is equal to minus 14.4. Okay, you can solve this two equation. Finally we get moment at A and moment at B. Now this is moment at A, that means negative. Left hand side negative is equal to anti-clockwise 9.6. MB is equal to again negative, and this is right hand side negative, that means clockwise 14.4. Now we find out support reaction for fixed beam because it is unsymmetrical loading. So we find out fixed beam support reaction. Okay, right here SF. Okay, support reaction SF calculation. Now mention here we find out support reaction with respect to any reference point, taking moment about A. Taking moment about A. Suppose here I assume that my support reaction RB is in up direction. Anti-clockwise moment is equal to clockwise moment. Mention here RB into distance is given 5 meter. RB into 5 and my anti-clockwise moment is given 9.6 plus 9.6. Okay. Now next this is my clockwise moment 20 into 3 mentioned in this side. 20 into 3 with respect to A point plus this is again clockwise moment 14.4 and my answer of RB is equal to 12.96 kilonewton of direction. Now next find out RA. Mention here RA is equal to total vertical load minus RB. My total vertical load is equal to 20. 20 minus 12.96 is equal to 7.04 kilonewton. It is also in up direction. Okay. Now mention here our first reaction is equal to 7.04 and RB we find out 12.96. Okay. Now we draw the SF diagram. This is our point load. So SF diagram is our in box form. RA up direction. So simply up 7 point go through this center point. Notation is given C point. Up to this we go constant. After 7.04 minus 20 and my answer is minus 12.96. So go down. Okay. And again go constant and finally match with this line. This is 12.96. 12.96 plus 7.04. Okay, this point is A, this point is B, and this is my SFD diagram. Okay, now moment at A and moment at B, we find out moment at C. For that, mention here we find moment at C from left hand side. Okay, mention here moment at C is equal to this left hand side moment is anti-clockwise minus, mention here minus moment at C we find out at this point moment, and this support reaction rotate clockwise, that means left hand side clockwise plus 7.04 into 3. Okay, plus 7.04 into 3 and my moment at C is equal to 11.52 kilonewton into meter. Now I draw the BM diagram. First of all, draw the reference line. This is our C point, this is our B point. Okay, one by one. Moment of A is equal to 9.6. Simply mark the point. C point is equal to 11.52 and moment at B is equal to 14.4. Okay, now one by one. Bottom line, that means negative, and diagram of bending moment diagram of this point load is inclined. Okay, simply connect this. Okay, now again connect this point, and from this plus, this is minus, this is minus, this point is 9.6, this point is 14.4, and here we find out 11.52. Okay, this is my bending moment diagram. Okay, now we complete this example. Okay, in next session we solve another example. Okay, just now we stop here.